Good morning to you all. Thank you for having me here. My name is Lillian Gonzalez. I am civil engineer, and I'm currently finishing up my PhD studies for the Florida Atlantic University. But this is not about me today. This is about my cousin's bachelor's thesis research. If you didn't know, in Cuba, in order to graduate with a bachelor's, you need to have a thesis. And he's an electrical engineer, so I did my best to translate electrical engineering to civil engineering so I can present it today. Before I begin, this is not a thought process. This is already being implemented in Cuba. So today I will start with the project description. I will talk about the objectives, a little bit about SCADA and PLCs, hardware programming elements, the economic and environmental factors, and finally I will conclude. So, Santa Maria Key, it's one of the second tourist attractions in the island after Varadero. It is located on the northeast coast of Villa Clara, Cuba. The current components are a pump station located in Caibarien. You have a water main running through the causeway from Caibarien to the Key, which is 60 kilometers, roughly 40 miles. There's a storage tank facility located in Santa Maria Key and different distribution points to the hotels at the Keys. Here we have an image, an overview of Cuba with the highlighted province of Villa Clara, and to the northeast you have Santa Maria Key. Here's a better diagram describing the location of each of the components. You have the pump station in Caibarien, the 60-kilometer water main to the Key, the storage tank station, and the distribution to the hotels. So what is happening currently? The automation is local. There's no supervision of the existing RTUs in the field. There's no control system to assess the conditions of the water supply, to measure the water being supplied to the hotels, to take measures if the system were to fail, and to measure the tank levels. So, what does this project propose? The rehabilitation of the pump station in Caibarien, the automation of the storage tank station and the distribution points located in Santa Maria Key, which are the different hotels, through an implementation of a control system to monitor, supervise, and assess, and the installation of a SCADA to take a visual representation of the system. There are going to be 5 points at which pressure is going to be measured, and the water consumption at the different distribution points is also going to be measured. The hotels are Estrella 1, Estrella 2, Melia Las Dunas, Santa Maria Key, and Madruguilla Hotel. And finally, we will establish a visualization process of the system at the command post. This is a diagram of the communications. You're going to have a SCADA system, which is going to provide visual control of the overall system. You're going to have 13 RTUs installed throughout, 1 at the tank station, 5 along the water main to measure pressure, 6 at the distribution points, which are the hotels, and 1 at the pump station. So what's SCADA? SCADA is designed to supervise, monitor, and control industrial processes. It communicates with field devices. It controls the processor from a computer screen, and it sends information to the operator. And this is a diagram of how SCADA communicates with the different field devices. Then we have the PLCs. They're a special purpose microcomputer. They're designed for industrial control and data acquisition. They use mixed elements in programming, and they perform in real time with great reliability. For the brand of the PLCs used in this project is the T-Box. Each controller can work independently even if the connection fails. They possess unmatched potential in communication and have low energy consumption. They can operate in battery or solar panels. They display excellent results proven in multiple applications in Cuba, in harsh environments and high humidity. Here is a diagram of how a T-Box, standard T-Box looks like. This is the wireless monitor ultra-low power T-Box, which is going to be located at the water main to measure pressure. The modular system T-Box, which is going to be located at the pump station and storage tank station. Besides the RT units, we're going to have an automatic control panel. This is very important. It is located on the pump and storage tank station. It overrides the SCADA automation. If the system were to fail, you can manually stop it and run it again if necessary. The elements are an emergency button, a manual automatic control, and a motor protection indicator for the pumps. There are going to be 8 electrovalves placed in the storage tank station, 2 at the entrance to monitor the water that is coming from the pump station, 4 to control the water levels at the tanks, and 2 at the supply or distribution points to the hotels to see how much water the hotels are consuming or how much water you are supplying to them. Here is a diagram of how the control panel looks like. You have the automatic and the manual indicators, and you can see on which mode the system is operating. You have an emergency button to stop the system in case of failure. You have a manual and automatic switch to switch the modes. You have 8 electrovalves located at the distribution tank stations, and also the state of the motors. There are going to be 5 pressure sensors along the water main. Siemens is going to be used. You're going to have a chlorine residual and water level meter, and various water level meters located at the hotel. This is a set of inputs and outputs, digital and analogs, that were used on the programmation of the system. And this is a visualization of how the programmation it was implemented. So less economic losses are going to be created due to the automation of the system. Security control and efficiency of the water supply are going to be provided. You're going to have a stable water supply to the hotels and less use of personnel to operate the system. Environmentally, you're just going to use water more efficiently. The energy savings are going to be enormous due to the automation of the pumps. In conclusion, we are installing SCADA software, 13 RTU units throughout different points in the distribution system, not only to collect data, but also to measure, not only to collect data, but also to work to control the different processes in the system. The installation of a control panel, different sensors and meters along the system. The upgrades and the rehabilitation to the existing water supply are necessary because tourism in Santa Maria Key has become a major source of income. Efficient water supply and distribution contribute to the economic growth of the country. So we can actually afford all the projects and ideas that we have seen today. Thank you.